All right. So I am. Let's gonna go over lesson 6 here today with you. What I am going to do at the end of the lesson, and I will. I'm not going to do this during the lesson. It's not going to be part of the video, but I will post a full review for you, a breakdown of what's going to be on the test, question by question. As well as some practice questions for you at the end. So this will be posted on, I'll have that review posted on OneNote and on D2L. Okay, so our test is Thursday. I will be back tomorrow to go over any review to review with you. But I'll give you the review questions will be posted by the end of this, during this period. So you can go take a look at those and try those out to get ready for the test on Thursday. So let's start here with what we're doing today. So the idea today is we're solving quadratic trig equations. Okay. So on last week, on Friday, I'm all mixed up in my days. Last week on Thursday, we solved linear trig equations. Okay. And with that lesson, I posted a video on D2L, which went over how to solve 4 examples of how to solve those, as well as I posted here, there's 5 examples of how to solve questions like that. Okay, the homework is posted there so that you can work through that. But solving quadratic trig equations is very similar to solving linear, except it's quadratic, right? So we have, which means our things are squared, right? If we think of just quickly here, if we think of solving a linear equation, we're solving something like x plus 2 equals 5, right? We're bringing our 2 to the other side, and we're getting x equals 5 minus 2, x equals 3, right? That's a linear equation. If we put a sign in front of that, that now becomes a linear trig equation, okay? Now that is not solvable, but hopefully you get the idea, okay? When I'm solving quadratic trig equations, or think about quadratic equations, I'm solving things like this. How do I solve that? I factor that. What 2 numbers multiply to 3? Negative 3, and add to 2. That's x minus 1 and x plus 3. So my solutions are x equals 1 and x equals negative 3. Okay? This will be very similar, but now we're going to put signs in front of that. So now we're going to say sine squared x plus 2 sine x minus 3. So we've now made this a trig quadratic by squaring that. Okay? These questions are solved very similar manner. You can do this by factoring often. Okay? So then I'm just going to read a little intro here before we get to some examples. But it says here, in some applications, the formula contains square of a trigonometric ratio. Okay? And this could be in physics, this could be in chemistry, this could be, depending on what area you're looking at, this could come up in a bunch of different areas involving mathematics. So this can lead to a quadratic trig equation that can be solved graphically or algebraically. We're going to focus on algebraically. Quadratic trig equations can often be not solved, by factoring. That should be solved, right? And we're going to say this is by factoring, okay? Just like we solve quadratics. In cases where the equation cannot be factored, use of the quadratic formula, and then solve the resulting linear trig equations, right? Just like quadratics in grade 10. Okay, you solve it using the quadratic formula or factoring. A quadratic trigonometric equation may involve or may have multiple solutions. Okay, this is really important. Multiple solutions in this interval. Some of the solutions may be inadmissible. However, in the context of the problem. So this is depending on the context of the problem. Okay? So let's go through a few examples. We'll start with the first one. So the first one says, find the exact solutions for tan x minus 4 tan x equals 0. Okay? with this first one, what we're going to do is we're going to look at this as, okay, I'm going to rewrite it. I'm going to write it as tan squared x minus 4 tan x equals 0. So I've rewritten it. Now, what you can think of this as is we can kind of modify this. And we could say, let x equal tan x. If that's the case, this equation becomes x squared minus 4x equals 0. Do we know how to solve that? Yeah, I do. I factor out x. We get x minus 4 equals 0. So my solutions are either x equals 0 or x equals 4. Okay? Those are my possible solutions. Now, because this is a tan function, okay, and remember we let tan equal, or x equal tan, we can put our tan x back in and we get tan x equals 0 or tan x equals 4. Okay, my last step when solving for x here would be to bring tan over and take the tan inverse of both of those values. So if I take, so I would say x equals the tan, actually let's stick with my green here. I would say x equals the tan inverse of 0 or x equals the tan inverse of 4. So we can come up with two solutions. I'm going to pull up my calculator. I don't know that off the top of my head, but we can do this in our calculator. We can do second function tan of 0 is 0. So we could say x equals 0 is one solution. I'll highlight that. And we could find our next solution. We'll go with tan inverse. So second tan of 4, 1.32. So we get x equals 1.32. Okay? So those are our two solutions. Now, let's go back to here. So you can also, let's hold on to those two solutions for just a moment. Okay? Now, what you can also do is you could do this just with this formula here. We could factor out tan. So we get tan x equals tan x minus 4 equals 0. Now that this is factored, we get either tan x equals 0 or tan x minus 4 equals 0. Notice that this here, these two here, are the exact same as these two here. Kind of those, right? If we finish solving those would be the same. So I'll just put little stars beside those. Okay, right? We bring the 4 over. So you can solve that either way. You can sometimes let x equal tan x, make it just a quadratic that you know that we've seen before, and then solve it that way. Or you can solve it the other way. You can solve it just leaving tan x in the formula. Okay. The only other thing that we need to take note of now is we need to take note of the fact that it's asking for all the solutions between 0 and 2 pi. Okay? So if we just take a quick look at our tan function, right? So let's just take a quick peek here. So if I go, let's go tan of x. Oh, wait. Tan of x, right? This is our graph. And I want to know, the question was asking when, so that's our function, right? That's what our tan function is. So we want to know two things. We want to know when tan, right? We're looking at two things. When is tan x, I'll go over to here. When is tan x equal to 0, right? There's one. And when is tan x equal to 4? There's another. So let's take a look at our graph and see where that happens. Well, tan x is equal to 0 right here, and right here. Okay, 3 spots between 0 and 2 pi. So there's 3 solutions there, okay? And where is tan x equal to negative 4? Well, let's just put it, watch this. Y equals negative 4. Let's just put that line in there. Where is tan x equal to negative 4? Well, it's negative 4 there, which is one of the solutions we found, I think, 1.8. Let's see, did we find that? Oh, oh no, not negative 4. Why did I put negative 4? Positive 4. 1.326. Do we find that? 1.32. That's correct. But then also here and here. That one's bigger than 2 pi. So it's only 2 pi. It's less than 2. So here's my 2 pi line. It's less than 2 pi here and here. So how do we find this other solution here? Interesting question. Well, let's go figure that out. Okay. In order to do that, so we have our two solutions, x equal to 0 and x equal to 1.32. In order to find our other solutions, what we're going to do, so I'm going to just put a star here, to find other solutions, add the period. Okay, so we're going to add the period. So we're going to do, and if we know the period of tan is pi, so to find my other solutions, I'm going to go, let's do it like this. We're going to go x equals 0 plus pi. So that's equal to, whoops. So that's equal to pi. So that's a solution. And then we're going to add another period. So then I'm going to find another one. We're going to go x equals pi plus pi. And that's equal to 2 pi. So that's a solution. Okay. Now, if I add pi again, we're outside of our interval. Okay, we would be at 3 pi, which is outside of the interval that it asks about in the question. So those are 2 more solutions. But let's now find my solutions for my other case. Let's do x equals 1.32 plus pi. And that's about, if we do that in our calculators, 3.14. That's 4.44. 4.46. Okay. That's how we find that one. So that's another solution. And now let's add pi to that. So notice how we're taking both of our solutions from here and we're adding pi to them. If we get outside of our zone, if we're bigger than 2 pi, then we've gone too far. So let's do 4.46 plus pi, and that's about 7.60. Notice that this is bigger than 2 pi. Because what's 2 pi? 2 pi is 6.28. So this is not a solution. So we stop and we have our 4 solutions. 5. 2, 3, 4, 5. All my highlighted solutions are my solutions. Okay. So these questions are tricky because you can have multiple solutions. Okay. So let's take a look at our next one. All right, we'll go through another one here. I'm just going to pause this for just one moment. Where's my... Okay, let's try the next one. So with the next one, I'm going to write it out. So I'm going to say, okay, 2, a little bit smaller there. So let's go 2 sine squared x plus sine x minus 1 equals 0. So what I'm going to do here is I'm going to say, well, let's let x equal sine x. So I'm going to take out my sine x. I'm going to put in x. So this becomes 2x squared plus x minus 1 equals 0. So just noticing that My square stays there. The second one plus sine x is not squared. Okay? Now, how do we factor this, right? So this is a question we're trying to factor, right? So these are ones that we always try to solve these. So let's think of, just think of this for a second. So we got to go two numbers that multiply to -2 and add to 1. This is decomposition because of our first number is a greater than 1. Okay, we have a coefficient in front of the x squared. So two numbers that multiply to -2 and add to 1 would be +2 and -1. So I decompose my middle term. So I get 2x squared plus 2x minus x minus 1 equals 0. So I'm going to keep factoring this. I'm going to factor out 2x. We get x plus 1. I'm going to factor out -1. I get x plus 1 equals 0. And then finally, finish my factor. I get 2x minus 1 bracket x plus 1 equals 0. So what are my solutions? Well, my solutions then are either x equals 1 over 2 or x equals -1. Okay? So now remember, we let x equal sine x. So I'm going to sub that back in. So I get sine x equals 1 over 2. I'm going to solve this. So I'm going to bring... Now, there's a variety of ways that you can do this. Okay? This is where our stuff from last unit really comes in handy. Okay? So in order to solve this one, I'm going to take my sine inverse, or you can think of this in terms of special triangles. But what I'm going to do is I'm going to take the sine inverse of that. So I get x equals the sine inverse of 1 over 2. I'm going to use my calculator. If you're not sure how to solve this, we need to make sure we practice this. But this is stuff from last unit. And again, depending on the calculator that you have, this can be done just like that. So that's pi over 6. Okay? So we say x equals pi over 6. You can do that using your special triangles. So that's one of our solutions. Okay? Now my other solution here is going to be when x equals -1. So let's figure that out. So let's go here. Actually, you know what? What I'm going to do is I'm actually going to build off of this. Because if we think of this, let's go with do our little Cartesian for our first one. So I'm going to draw my Cartesian. And I get sine of pi over 6. So that's here. Where is sine positive? It's here and here. So if this little angle I just found is pi over 6, what is this angle? Well, that's 5 pi over 6. Okay, because this angle here is pi over 6, and this is 6 pi over 6. Right, so pi over 6, or 6 pi minus pi over 6 gives us 5 pi over 6. So my other solution here is, let me just erase this. My other solution here is 5 pi over 6. Okay? So there's my two solutions. Now I'm going to go do my other side. When is sine... Oh, shoot, I froze. Give me one sec. When is sine x equal to -1? Well, when I'm solving these, I always just look at my graph. So my graph for sine x looks like this. When is it -1? That's this point right here, which if you know your sine, that's 3 pi over 2. Okay? You could also take the sine inverse of -1. So I'll show you that method as well. So if I bring my sine over here, I get x equals the sine inverse of -1. Let's see if my calculator will do that one for me. Second sign of negative 1 is negative pi over 2, or negative pi over 2, which simplifies, right, we add 2 pi to that, we get 3 pi over 2. So my solution there is x equals 3 pi over 2, okay? And between 0 and 2 pi, it's only that value once. So there are my 3 solutions, okay? So again, knowing how to solve these, which we did last unit, I'm going to highlight them actually in a different color. Knowing how to solve these ones here is very, very important for this stuff, okay? And this is from the work or the lesson that we did last Thursday, okay? So you need to know how to solve those. Okay, let's try this next one here. So again, with this one, notice how, well, I'm just going to right away write this as 6. Actually, we're going to say, let's say let x equal cos x. Okay, so I'm going to take out any coses, I'm going to put in x. So this becomes 6x squared minus x minus 5 equals 0. I want to factor this, okay? So I'm just going to factor this, and if I factor this, what do I get? Well, I need two numbers that multiply to equal negative 30 and add to equal negative 1. Well, it's 6 and 5. It's going to be 5 minus 6. So let's write this. So I'm going to break this down into those two values. So I have 6x squared minus 6x plus 5x minus 5 equals 0. So again, we're just factoring. I'm going to factor out 6x. I get x minus 1. I'm going to factor out a 5, so plus 5. I get x minus 1 equals 0. So my solutions are 6x plus 5 and x minus 1 equals 0. So then let's look at my solutions here. Okay, my solutions are either x equals negative 5 over 6 or x equals positive 1. Okay, how much space do I have? So what I'm going to do now is I'm going to bring this little note to over here. I'm going to focus on this one first. So we're going to sub cos back in. So we get cos of x equals 5 over 6. I'm going to rearrange. I'm going to do x equals the cos inverse of 5 over 6. Oh, sorry, negative. I should have negative there. And so we get x equals, let's use my calculator. So that's second cos of bracket negative 5 divided by 6, 2.55. So that gives me, that was correct, right? Yep. So that's 2.55. So that's one solution. Let's highlight I always like to highlight my solutions. Okay. Can I find more solutions? So remember, if I want to find more solutions, I add my period. Add period. In this case. In this case, I'm not going to find, in this case, for this one, I'm not going to add my period because where is cos negative? Cos is negative here and here, right? So this angle here is 2.55. Now, my other solution would be this angle here. But notice in the question that it wants my solutions between 0 and pi. That blue angle is bigger than pi. So that is not going to be a solution. Okay? So we're done. So that's my only solution there. Then we're going to solve my other one. I'm going to do that one in a different color here. I'll do that one in this color. So x equals 1. So my question is, when is cos x equal to 1? Well, if you know anything, if you know the cos graph, my cos graph looks like this. It's equal to 1 when x is 0. And you can try to take the cos inverse of that. X equals the cos inverse of 1. And when you do that, you get 0. Notice that the next time it's at 1 is at 2 pi, which is greater than our interval that it's asking about. So we only have 2 solutions in this case. Okay. 3 examples left. Okay. Let's try another one. Okay. This question here is a little bit more complicated because it is looking at a reciprocal function. Okay. So with this one, with our reciprocal function, this is the last example I'm going to do in this video, and then I have to leave, and I'll film the second half of this a little bit later. Okay. So with this example here, notice that we have secant and we have cos. Okay, that's a bit of an issue because they're different, right? They're not the same ratios. So what we're going to do here is, this is where our identity work comes in handy. I'm going to change that secant 2x, and I'm going to change that to 1 over cos 2x. Okay, plus 1 over cos x equals 0. Okay, now again, it's really important to notice where we have our identity. So cos 2x is actually equal to, and if we pull up our, or if you take a look at your formula sheets, we can write that in a different way. We can write that as cos 2x is equal to 2 cos squared x minus 1. So I'm going to actually substitute that into my formula. Okay? So watch how I do this. So what we're going to do is we're going to substitute that into my formula. So we're going to go 1 over 2 cos squared x minus 1 plus 1 over cos of x equals 0. Now, anytime we're dealing with these questions, notice this is now a reciprocal function or a rational function. When we're dealing with a rational function, we need to get a common denominator. So my common denominator is going to be these two factors here. So I'm going to multiply the top of this function. Hello? I'm just going to pause this for a minute. So I'm going to multiply, I'm going to kind of cross multiply here. I'm going to multiply the top of this function, or the top and bottom of this function, by 2 cos squared x minus 1, and the bottom by 2 cos squared x minus 1. I'm going to do the same over here. I'm going to multiply this one by cos x and cos x. That's going to get me a common denominator. So what I have is I have cos x plus 2 cos squared x minus 1 all over 2 cos squared x minus, minus 1 times cos x equals 0. Now, if you remember from our rational functions unit, when I'm solving a rational function, I can cross multiply my denominator, and I can multiply my denominator over there by 0. Now, when I multiply that whole denominator by 0, it goes away, okay? Because 0 times all of that is just 0. And so what I end up having is I just have my numerator which is cos x plus 2 cos squared x minus 1 equals 0. Now I'm just going to rewrite that. I'm going to say I'm going to rewrite that. I'm going to change the order. I'm going to go 2 cos squared x plus cos x minus 1 equals 0. And then I'm going to say, do what I've been doing. I'm going to say let x equal cos x. So we get 2x squared plus x minus 1 equals 0. If you notice this from earlier, we know and we factored that earlier. So I'm just going to scroll up a little bit to show you that. Okay, we factored that same thing right here. Okay, and I'm just going to use what I did from before. Okay, I know what that factors to. So rather than going through the process of factoring that again, I know that this factors to 2x minus 1 and x plus 1 equals 0. So my solutions are either x equals 1 over 2 or x equals negative 1. Okay. Now again, I look for my solutions here. So I sub cos back in. So I'm going to say, okay, cos of x equals 1 over 2. I'm going to bring cos over, take the inverse of that. So x equals the cos inverse of 1 over 2. Using our calculators, okay? Or special triangles. If you notice that that's a special triangle, we're taking the second cos of bracket 1 divided by 2. I get pi over 3. So x equals pi over 3. So what I can do is I can actually draw that using my special triangles. So remember, cos is positive here and here. So this angle here is pi over 3. What is this angle here? That's 7. No, sorry. Oh boy, why am I blanking? To figure out that angle here, I'm going to go 2 pi minus pi over 3. And that's equal to, why am I blanking? 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay, so that angle there is 5 pi over 3. So that's my other solution. So those are my two solutions there. Now I have to solve my other one. So I'll do that below. Or x equals negative 1. So we say cos x equals negative 1. Well, I always like to do these ones if it's 1 or negative 1. I always like to just think of what my graph looks like. And my graph of cos looks like this, where this is 2 pi. This is pi. So when is the cos graph negative 1? Well, at pi. Okay? So I know that x is equal to pi. Now you could bring cos over, and you could take x equals the cos inverse of negative 1, which if I just do that on my calculator quick, second cos of negative 1 is pi. Okay? So you get your other solution there. Now, it's always good to check back at our question, and I'm just noticing right now that my solutions, it said had to be in the interval 0 to pi, so I actually don't need this solution. That's 5 pi over 3 is bigger than pi, so that solution is inadmissible. I'm going to pause this video now. I'm going to film the other video later today.